Hello and welcome to another video. In this video we're going to be working on a number of ways to split array. And in this one you have a zero index integer array nums of length n, and there's a valid split index I if the following are true. The sum of the first I plus 1 elements is greater than or equal to the sum of the last elements. And there's at least one element to the right of I. So basically they're just saying split an array into two non-empty arrays. Like as long as that's fine, then that's a valid split. And then the left side has to be greater. So in this, they tell you one way is like this. So here we have 11 minus 8, which is 3. And then we have 10 here, so this is valid. And then other ones like this, also valid. And then if we do something like this, then this would be smaller, so this wouldn't be valid. And then we can't have empty arrays, so it's just those two. And then let's take a look at this one. So just by looking at it, so this is a valid split. Actually, it's not, because the left side has to be bigger. So this is a valid split, 5 and 1, and also this one. So there's kind of two ways to do this, and one's definitely just better than the other. And what you can do, like essentially, like the brute force of this problem would just be if we have some array. Let's just say we have some random array full of numbers. We can basically just say like, all right, let's just have a split index, and then we'll just get a sum for the left and the sum for the right, and if the left is bigger, then we'll return true. So essentially, for example, we can say like, we'll split after some index, like maybe after index 0, we'll split here, calculate a total, see which one's bigger. Then we'll split here, calculate a total, and so on. And so the brute force would be n squared, which wouldn't be good. The better solution is to have a prefix sum. So essentially with a prefix sum, you would just compute a total ahead of time, and then you can just get totals in of 1 with a prefix sum, because that's basically what it does. So essentially you could say like, okay, for this chunk, I'm going to look at my prefix sum for what's this total, and then get that for this chunk, and so on. So you can get these in O of 1. The problem with that is your prefix sum is going to be O of n space, so this will be like n. So the better way to do it is just calculate a total beforehand. So essentially we'll just calculate some total x. And then as we go, this total will actually be the sum of the right side, like the right side of the split. So we'll call this like right. And then the left will be 0. And then we can essentially just start splitting. And every time we split, we're just going to take whatever number we're adding to the left, subtract it from the right total, and add it to the left total. So for this index, it'll be like x minus index 0, and this will be whatever was at index 0. And then we'll check like, is this bigger? Then we're going to move on to the next one. Then we're going to subtract index 1. And then we're going to add it to the left and check, is it bigger, and so on and so on and so on. At index 1. So essentially just to do like a quick dry run of some random numbers. So let's just say we have like 9, 3, 4, 8, -8. We don't need too many numbers. I think honestly like we'll have like 2 more or something, and that's fine. So let's just say we have 2, 1. Get rid of all that. Okay. So essentially the total here starts off as 12, 16, 24, 16, and then this, so 19. And then here is 0. Yeah. And then our result starts off as 0. So we have to have a non-empty split, so we have to make sure there's at least something here. So first we're going to say, like, let's add this number to the left. So essentially our split will be right here. So if we subtract it from the right, add it to the left, so right's 10, left is 9. Is this good? No, because left has to be bigger. So then we keep going. So now we do a split like this. So this is the new number we're subtracting from the right. So this will be 7, and this will be 12. So this is a valid split. So result will be 1 here. And then we're going to do the same thing. Add to the left. So add a 4 to the left. Subtract from the right. Yeah, this is also valid. So we have increment. Then do this. So add to the left, subtract from the right. Yeah. Okay, and then, yeah, whatever, it's fine. And then this is also valid, so 3. And you can see this is like correct, right? This is -5, so we keep going. And basically the left is just going to be bigger for all of these from now on. So we can do this again. So now we will add to the left, subtract from the right. So now our right total is 3, and subtract -8. So, or add -8, so it's 16. This is also fine. And then this one. So 18 and 1, also fine. And then finally, we don't want to do this one because then the right side will be empty. So essentially we have 5 valid splits here. And if we just quickly double check that, so this is not valid. This one starts off as being valid. So 1, 2, 3, 4, 5. And yeah, you can't have empty arrays, and that's basically going to be it. So let's just code that. So let's pre-compute the total first. We can set that as like the right half. So we'll just say right is 0, and left is also 0. And we'll just go through every number in here. This is basically the same as in Python, a for loop where you don't use an index. So we can just say right plus equals num. Except you just say range. Okay, there you go. And now we essentially do the same thing, but we want to make sure we only do splits at valid indices. So we want to make sure we have non-empty arrays. So we'll just use a normal for loop here. So we'll just say whatever index we're at, let's add that to the left, and then we'll do the split right after that one. So I is less than length nums minus 1 because we can't have the whole array in the left. So essentially it's just 1 less than the full array. And then we're just going to say left equals nums I, and subtract it from the right. And then also make a result variable. And we'll just say if left is greater than or equal to right, then we'll increment result. And that should be it. Okay. Yep. Okay. So yeah, so hopefully that makes sense how like the brute force is n squared here, prefix sums is n, but n space, and then this is the optimal, just doing a pre-compute and then just using a variable. So this is linear and 1. Yeah, and that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.